Okay, right, hello everyone. Gonna make a quick recording. Hopefully that's recording and hopefully it's recording my voice. I'm going to make a quick recording just showing you the steps to run through a correlation analysis, SPSS, and then how to do a partial correlation analysis controlling for another variable. So what I'm going to use to kind of demonstrate these analyses is this data set about exam anxiety, which comes with the core textbook for the module, the anti-field textbook. Okay, so it's got, as you can see on the data file, the SPSS data file that's up on the screen, there's 5 variables. The first one's called code, that's just the participants' sort of ID number they've given them. The second variable is revise, and that's a measure of how much time the participants spent revising. The next one is exam, and this variable is their exam performance, so the score as a percentage of what they've got on an exam. And the third variable, or the fourth variable, generally is something called anxiety, which is a measure of exam anxiety. So higher anxiety, higher scores, higher anxiety about exams. And the last variable there is a variable for sex, male and female. And the ones that we're going to look at today are the time spent revising, the exam anxiety score, and their performance in the exam. And we're going to do a correlation analysis to assess that. Okay, so to do this, pretty straightforward in SPSS. Firstly, we'll do a bivariate correlation of all 3 of those variables. So if I click on Analyze, Correlate, and Bivariate, brings up this pop-up box, and the ones we're interested in are the revise variable, time spent revising, the exam performance, and exam anxiety variable. So we'll move them over. And the correlation coefficient I'm going to look at for these is Pearson's R. So that's the only one that's ticked here. The others available there, Kendall's tau and Spearman's rho, they're kind of more non-parametric. Robust coefficients, we're not going to bother with those at the moment. Okay, so if I click on options, brings up this little pop-up box, and I'm just going to ask for means and standard deviations as well. Okay, so click continue, click OK, and I'll make this screen bigger. You get the usual second window with the output in for SPSS, and you can see there is the result of our correlation analysis. The first table is a table of descriptive statistics, shows the mean, standard deviation, and number of participants. The ends for this particular data set, and then underneath we've got the table, this matrix of correlation coefficients. And you can see you've got the 3 columns represent the 3 variables, columns represent 3 variables, and so do the rows. So hopefully everyone has seen a correlation matrix before, where you can see the diagonal elements have all got a correlation coefficient of 1, because they represent each variable correlated with itself, and obviously it correlates perfectly with itself. But what we're interested in is either the output that's underneath that diagonal or the one above. It's a mirror, it's mirrored across the diagonal, so it's the same information. And if we look here at the second row, exam performance, and the first column, here we can see a correlation coefficient for exam performance correlated with time spent revising, and that has a correlation coefficient of 0.397. It's got 2 asterisks next to it, which indicates it's significant at the 0.01 level, and if we look at the output there, it's indicated that it's less than 0.001. Okay, so we've got a significant correlation between exam performance and time spent revising in this first box here, this first pair of variables that we're correlating. So what that's telling us, it's a positive correlation, so the direction is positive. As exam performance, as time spent revising increases, so does people's exam performance. Okay, and it's a significant result. Okay, we could look at a couple of others as well. If we look at the third row there, exam anxiety, and again time spent revising, we see a Pearson's correlation coefficient of negative 0.709, so about negative 0.71. That's a very strong correlation. It's a high correlation, and again, it is statistically significant. The p is less than 0.001 level. Okay, and this time the direction of the correlation is negative. So the less time people spent revising, the higher their exam anxiety, and that's showing a statistically significant result. And the three things, as I've mentioned in the lectures, the three things that you need to look for when you're looking at correlation are the size of the correlation, whether or not it's significant, and the direction of the correlation. Okay, so that is there's obviously a third correlation that we could look at as well there, which is exam anxiety correlated with exam performance, and we can see there's a Pearson correlation coefficient of negative 0.441, and again that's highly statistically significant at the less than 0.001 level. Okay, so again we've got negatives, we've got a significant negative correlation. What that's telling us is that as exam anxiety increased, exam performance decreased. Okay, so all three are significant. The directions of the relationships differ, and they differ in the size of the correlation. So 0.3, 0.4, negative 0.4, negative 0.7. They're all kind of two of them are the exam performance time spent revising correlation 0.397. That's kind of a medium effect size. Exam anxiety and exam performance negative 0.441. That's also a medium effect size. But the correlation between exam anxiety and time spent revising negative 0.709. That's a very large effect size in the case of correlations that you might see in psychology or social science disciplines. Okay, so that is how to just run a simple bivariate correlation analysis. What I'll do now is run a slightly different analysis on the same data set, where I'll do a partial correlation analysis and control for time spent revising. We'll see how that affects the results. Okay, so to do that, it's similar to the first, but we click Analyze, Correlate. You can see we've got another option here of partial correlation, so we're going to click on that this time. And we're going to ask for the correlation between exam performance and exam anxiety, whilst controlling for time spent revising. So we're going to partial out the variance that's accounted for by time spent revising. Okay, options. I will ask for means and standard deviations. I'm not going to ask for zero order correlations. What that means is just the basic bivariate correlations. We don't need them in this case because we've already got them in the previous table where we ran the first analysis. Okay. So if I click OK, that'll run this for us. And this time for our partial correlation, we've got a table of descriptives again, same sort of means, standard deviations, and ends. And this time, what we're seeing in the correlation table is a exam anxiety correlated with exam performance, but you can see there's this extra column here that says controlling for time spent revising. So we're partialing out the influence of time spent revising, or the amount of the variance explained by time spent revising, because all three of these are correlated to some extent. And what we can see here is we've got a correlation between exam anxiety and exam performance of negative 0.247. It is statistically significant, so the significance level there is 0.012. So it is significant at the 0.5 level, 0.05 level. Excuse me. But as you can see here, the difference between this analysis and the first analysis is the actual correlation between exam anxiety and exam performance has diminished. It's reduced by about half. Well, it's reduced considerably. It's still significant, but it's reduced considerably just by controlling for, by partially now, the influence that revision has. So we're still seeing a negative significant correlation where those who with higher anxiety have lower exam performance, but some of the shared variance accounted for by revision time has been removed in this case. Okay, so what that means, if we square the correlation coefficient to get R squared as a measure of shared variance, what we can see is that the first correlation, the R squared, would have been about 19% of shared variance between those two. But now, once we take control for time spent revising, that goes down to about only 6% of shared variance is explained by the correlation between these two particular variables. Okay, so that is how to run a bivariate correlation and a partial correlation. Hopefully that is useful, and I'm going to stop recording.